Vasant, good afternoon. Can I start the presentation, Vijay? Respected participants and enthusiastic participants and students of various engineering colleges and MVSR Engineering College. As Head Department of Automobile Engineering, I welcome you all for this session. I would like to present my particular topic. This is on, can you all see my presentation? Yeah. This particular presentation has been sketched up with the various experiences and expertises which I have acquired over last 25 years in the areas of fluid dynamics. As my particular topic is mostly on the practical aspects pertaining to the ANSYS, I'm trying to put up a topic on high-speed automobile testing in virtual wind tunnel using CFD. Whenever you look at applications, because you are being getting understood to all this particular jargons over period of time, wherein you are talking about how you make finite element analysis and finite volume methods. This does not come across in finite elements, but it comes under finite volume techniques because we deal with fluids. Now, there is one particular module which we call it as fluent. In fact, when I started working on Fluent, Fluent was only a solver. It used to use semi-implicit pressure-linked equilibrium equations to do. Those days, we used to do modeling on Gambit, and through Gambit, we used to, import the meshed model to Fluent, and Fluent used to read the meshed model, and then used to do. But over a period of time, maybe last 15 years, it has exponentially grown into a very commercial software used for computational fluid dynamics. In fact, there is another open source software by name OpenFOAM. OpenFOAM is open source software where you can directly use it for your CFD analysis. So, scope of the lecture, you have a problem statement, introduction to ANSYS workbench, which I may skip it because Karthik has been doing it, drawing drafting of automobiles of known geometry in 2D using ANSYS design modeler, because most of them use your drafting tools like AutoCAD, CAD 360, or you use OnShape like a cloud-based one, or SimScale, or you use SolidWorks, CATIA, but I will try to look into the known domain of ANSYS. It has a design modeler, meshing, setup in Fluent, solving in Fluent, solution, post-processing, challenges and discussions. Prior going into it, because I was using this particular word, high-speed automobile testing, I would try to say speed kills. It thrills, but it always kills. If you look at a road safety, it's not a caption, but it is need of hour, because morning, whenever I log up into my computer and then see the updates, I just come across like there's a severe accident on road. It's not one life, it's a family. And if you observe it technically, higher the speed of vehicle, shorter the time a driver has to stop, which you call it as reaction times. If an alert driver will have a reaction time within 0.5 seconds, a lazy driver will have around 1.5. Fellow who is abused with drug, alcoholic, will take the reaction time for 3 seconds, and it is fatal. If you observe it, the drive pedal, the brake pedal which you are trying to press, takes a reaction time of 3 seconds for braking action. For same speed, the stopping distances vary. Say suppose a car traveling at 50 kmph will typically require 13 meters in which to stop, while a car traveling at 40 kilometers per hour will stop in less than 8.5 meters. If you observe it, this 4.5 meters, approximately around, say suppose if it is 5 meters, say suppose I take it as 5 meters, 5 into 3, 15 feet, it is catastrophic. This is where accidents generally occur. Now there's a point which World Health Organization generally puts up on road safety, saying that if you drive at 60 kilometers per hour and you drive your car at 65 kilometers per hour, with increasing speed from 60 to 65, because your economic speed is around 45 to 60, and when you try to throttle more and you go at around 65 kmph, the occurrence of traffic, the probability of occurrence of the traffic is twice as that you go at 60 kmph. So my dear friends, those who are the target audience for this particular things, don't get excited with high speeds, because I've seen crazy fellows in this world who drive at around 200 miles per hour. It's approximately 300 kilometers per hour, and feel like, I did it. It's not so. You have to be very careful. Though my analysis is on high speed automobiles, I don't advocate use of high speed more than 60 kmph, because you take care of engine will take care of you, or else this reaction time is less than 0.5 seconds, which is definitely a problem. So with this particular social cause advocacy, I will try to go into the actual problem statements. Now, what is the problem with high speeds for automobiles? Because whenever I look at high speed automobiles, they have to be tested for aerodynamic things. Various reasons are there. The first one is at high speeds and high lateral acceleration, because in our terminology, we talk about high value of G. G is 9.81 meters per second. Say you take it as 10 meters per second square. So high value of G, we call it as 2G, 3G, and 4G, because whenever you are testing any particular structures for side impact, you say a load of 4G is being applied or 5G is being applied. So it is you talk in terms of per unit mass, what acceleration you're getting it. That mass into acceleration is giving you that particular force. So this is a general terminology. Hence, for high lateral accelerations, lateral tire to road forces are saturated, and the vehicle will lose the lateral stabilities. This is the biggest problem, and this particular problem is identified maybe around 70-80 years back. And you could not address it properly. You could not address. I am for sure, with all my expertise in the area of fluid dynamics, I could clearly say that this particular problem is not yet 100% solved. And you cannot even solve it. It is because of the lift and drag forces, which the fluid is trying to create, is trying to reduce the lateral tire to road contact, because whenever you have a lift, the tires will lose the contact. The moment the tires lose contact, there's no steer, nothing. You don't feel like that lateral stability is gone. You are trying to maneuver across the corner and you cannot do it. One particular example which I want to quote to the august audience is, like very recently there was one particular road accident, maybe 1.5 years back, prior to COVID, or maybe in the time of COVID. You could see a Volkswagen Venta car, running over the rails from the flyover at IKEA near Gachibowli. And when people have started looking at it, into it, like what I can call is motor vehicle inspectors, I can say road traffic police, and the one who has laid the roads, R&B, all statutory bodies, whenever they are coming down, they were just looking at the excess speed, because there was a curve, and it has to take that particular curve at a speed of around 90 kmph. The vehicle just took it. It is no longer on the road. I can call it as mobility. It was in air, and then it was fatal. It just went over somebody who was standing beneath, and then it's gone. There's no life anymore. And if you observe it, the maneuvering across the corners is the biggest problem whenever you lose this. People say that it is because of the centrifugal forces. I do agree, centrifugal forces need not be of such a high magnitude at 90 kmph, but it is because of the gyro reactions, and the wheel lateral stability has been lost, and no longer the driver could steer. There's no point of steer. That is one particular aspect. And second, in order to increase the safety of the road vehicles, various active safety systems has been proposed and developed. Yes, we have done it. Now, how long we have done it? We have done it depending upon the experiences that the drivers have come across over the roads. And these active safety systems include active front and rear steering, you have torque vectoring, braking, differential braking, active camber control, active roll movement control, etc. Everything. It's all complete mechanics, classical mechanics talks about it. Because of this gyro effects, you observe that the vehicle is no longer in stable condition in the plane perpendicular to your spin as well as your precisions. Essentially, all these active safety systems are manipulating longitudinal and lateral forces and aligning torques at contact patches of tire or road to improve the yaw and roll stability of the road vehicles. I have seen the other day watching one sport. Now I was trying to look at high-speed racing. You just observe only in a sports channel, and when you see people going at around 200, 250 miles per hour at the time of taking a turn across highly laid track, standard testing track, you could see that the driver is thrown in one particular direction and the vehicle is it is rolled. You can see that roll, instability of it. All these things happen. It happens because you are moving at high speeds. So is there any other possibility for us with the aerodynamic testing such that you can see to it, you can enhance the lateral stability of high speed vehicles? If you have more drag, actually the calculations is like this. If I dump 1 liter of petrol into your fuel tank, your approximate energy which you are giving it is around 45 megajoules per kg per nm cubes. Now I have brake thermal efficiency of around 24%. I don't see more than that, or if not, you can take thumb rule 30%, 33%. So 15 megajoules. Traction, mechanical losses, if you take it out, 15 is coming to 5 megajoules, 1/3 again. So the active amount of energy that is used for traction is between 8 to 13%. This is one reason why people have switched away from your fuel-based vehicles, and they're talking in terms of electric vehicles, which is a different terminology whenever you do that exergy calculations of this. My point is, if drag is more, I have the speed of the vehicle is reduced by around another 1%. So I have to reduce the drag. Drag is definitely a point of concern whenever you are going with systems, propulsive systems. The second one is lift. The drag coefficient and the drag forces are high, but lift is less dominant at lower speeds. The moment you cruise at higher speeds, you observe clearly that there is a lift. If you want to calculate the lift, whatever the pressure you have it, try to write it in terms of your dynamic pressure values. Dynamic pressure is given straight from your Bernoulli's equation. P by rho g plus v square by 2g plus h equal to 0. This is Bernoulli's equation in terms of head, meters, unit. Suppose you write in terms of pressure, P plus half rho v square plus rho g h is equal to constant. First term is static or stagnation pressures. The second one is dynamic pressure. This dynamic pressure multiplied by the coefficient of lift will give you into surface area, frontal areas will give you your lift force. If there is at least 3% of the total vehicle weight is the lift, then automatically you observe clearly that more than its weight of the vehicle, you observe that the contact is lost. And no steering. There is no steering. There is no internet in your car. Let me tell you, there is no power windows, no power steering, nothing. You have lost contact. When you have lost contact, it is up to the God, or it is up to the air. Here I will feel like air is my God. So it is up to air to take that particular vehicle in whichever direction it wants. And direction where this particular vehicle is moved is in the direction of the imbalance of all the forces acting on that particular vehicle, which God knows. Sometimes they may be there, they may not be there. You can refer to this particular, review of active aerodynamic control for increasing safety of high-speed road vehicles. Wonderful article from ResearchGate. So you have to look at yaw and roll stabilities. You have to road condition and vehicle payload, cornering maneuvers are always the biggest problem at high speeds, which will enhance about your lateral stabilities. So my particular topic, what I will do, I'll just roll down to one particular value, start, one more window wherein I'll try to practically draw and show you how to make things. Because I'm a small man, I'm a teacher. I teach for students. And I'll teach so in such a way that my students, my in the sense the target audience, gets at least, carry away at least a part of, 5 minutes of my lecture so that, it will be very useful. So what I did is I just made sedan as well as hatchback, because if you look at the sedan and hatchback, there are two particular, classifications of this car based on its body building. If you want to have a more leg space, because they say that on the chassis frame, if you have a 3-box, built up, then you call it as a sedan, and which has, more length. And when it comes back for your hatchback, your height and clearance has to be, more. So what I did is I just went out with one particular sedan model. I just took this is a wind tunnel which I took it, and it is something like from here air will enter. This is the car body. So whichever you are seeing in gray area is all fluid, because I am not going on solids, I am going on fluids. My area is nowhere I'll talk about any of the solid, I'll talk only about the fluid flows. So what I did is I just created an area. I'll show you how to create such areas. And then I just, called it as complete fluid. And I said this is the inlet, because air is coming like this. And this is how, air goes out. This is inlet and this is outlet. This is a wall, this is a ground. I have not included tires over here. And then, because the moment I include tires, I should go with a three-dimensional model. So what I did is I just went out with a 2D model, and then this particular D is again the top portion of your wind tunnel, and this is the car wall. Then what I did is I have meshed. I used a mesher, because other day Vishnu was telling us how to do mesh, and then I just meshed it. I imported it into Fluent. I took, turbulence, because I was talking about, high speeds, standard realizable functions. I was also solving for energy equation. And I have kept boundary conditions. And I started assessing analysis. So what I'll do, I'll try to immediately walk over, start my ANSYS, walk over, come back up to this particular point, then we will go with the further discussions. So I'm stopping my PPT here. 1 minute. No, not this. Yeah. So I'll start from the first new. Yeah, I have to solve. Yeah, maybe I'll save here. Save 1, 2, 3. Some project. This is the workbench which other day Karthik Darshekar sir was telling you all. I was asking it to mesh the new one. 2 minutes. Now this is a new one wherein This is your analysis systems. And if you see R2122, R2021 release 2, ANSYS is completely different. I am used with ANSYS 15. So what I am doing is I'm trying to go to Fluent, Fluid Flow. We have different solvers. If you want to solve, plastic fluid flows, molds and all, you can go with blow molding, extrusion, and polyflow, because at high temperature, as the temperature is more than its melting point, they are fluid. So here I'll say car flow analysis, flow over car. Then I'll click the geometry, double click. It's taking time. Yeah, this is beauty of ANSYS designer model. Now, why I tell you to use ANSYS designer model whenever you're going with analysis is one particular point which I want to tell you all this modeling softwares, whenever you import geometry from either SolidWorks, CATIA or AutoCAD, they are imported in IGES, International Graphic Exchange File Systems, IGES formats. But the biggest problem is they will lose, some areas are lost. You call it as patching. We always feel like you have a modeling, then you have a meshing, then you have a solution, then post-processing. No. In industry, you have a modeling team, geometric modeling team, and when it is being imported into the measure model using hypermeasure rod, there in between you will have a patch. And patching is the biggest team. This is where the biggest team they identify. I'll see which particular areas have been lost, because whatever volumes we are being doing, it is very small volumes, but the volumes which industry does are very high, and they have a commercial impact. If analysis is wrong and something goes out of their hand, gone into the production, released into the market, after sales have to return back all the particular vehicles, which is the biggest issues. So what I tell you is, whenever you're trying to use it, ease out your geometry, or if you have a proper patcher, you do it. This is, look at me, and I go to Sketcher, take a rectangle. Now wait, I'll try to keep my units. Yeah, you can keep your units in whichever format you want it. I'll take foot. No. Then go to dimension, general dimension. This is, I'll take a wind tunnel of 30 feet. And height.
Excuse me, sir.
Yes.
Sir, I don't think that the screen you're doing it on is visible to us.
Is it? Is it? Okay. 1 minute. 1 minute. I'll just. What has happened? Yeah, I could understand. Now it is because it has opened another window. What it did is it opened another window. I have not opened that window. I'm sorry. Thank you very much. I'll start over. I'll start over.
Yeah, thank you, sir.
Yeah. Thanks, or else I would have been, moving through in the particular thing. Now, this is XY plane. On an XY plane, I'm trying to change the unit to foot. Industry is still in FPS, and please do so. And I just take a tunnel, a simple rectangle, wherein I dimension it, keep some 30 feet, then take this particular dimension, take it around 15 feet, get it back. This is one. Then I'll try to sketch lines. Say, I'll try to put its dimension, because from horizontal I'll at least this should be at least 15 feet, 5 meters in fact. That's wind tunnel, testing methods. I'll try to take some gradient. This is my windscreen. I'm just drawing it, but automobile has so many restrictions on its geometry. Please don't do it like this. Please take some known dimensions and then work it out. This I will change it to 45 feet. Yeah. Keep some constraints on the horizontal. Yeah. And put a dimension of angle on the windscreen. Yeah. This particular angle. Generally people say it is around 65 to 70. So I'll take around 70 degrees. Because we have standards. It's not like I am telling it. That's the standard, and you can always take a dimension. But this is more. I'm seeing this should be around say 50. Bad. No, it went away. This is good. For me, this is good to tell you the analysis, because we have two things. One is either you complicate geometry, that is how people live with drafting softwares. Other one is keep your geometry simple, complicate physics. That's how we analysis people live. But there's another scenario where you have a complicated geometry and complicated physics. This is how industry lives. That's how business has been developed. So I'll try to go with concept, make surface. And then I will also select this. I'll select all this. Then say generate. It has generated. I did it. Now this domain, if you observe, this domain is saying solid. It should not be solid. If you do solid, gone. It has to be fluid. Now I have a tunnel. Right. Now this has to be, I'll stop it. Now if you observe it in the workbench, your first geometry is done. It is saying, yeah, I did it. So next is you mesh. It is structured, systematic. So it has opened one more window. This is your measure. It gives you complete date and timestamps, everything. Yeah, this is what it does. If you want, click it, make it normal. Anywhere you can see the isometric. So I generally used to go with this. For ease, you can zoom in and zoom out. What you do, select edge, this edge. This is edge. This is a point, this is the edge, this is the surface. This is volume. I'll go with edge. Go to this, right click, create named selection, because this is where it is telling you which particular boundary is what. So this is your inlet wind tunnel, inlet wind tunnel. So this has to be exit wind tunnel. Now, in fact, this is the top portion of your wind tunnel, so I can call it as ceiling, and this is your ground. Then I'll go for box select. Yeah, all that particular surface has been now selected, and then call it as vehicle body. Two-dimensional is easy to understand. Three-dimensional, when you're going it, you should go for thin surface and then keep it in a cuboid. You have to use Boolean operation. You have to subtract one volume from the other, ask it to retain the particular volumes. You will get the required shapes. But for now, so if you look at it, you have inlet wind tunnel, exit wind tunnel, have a ceiling, have a ground, and you have a vehicle body. This is what you have. Now you ask it to generate mesh, it will do it for you. I still believe the the lecture given by Anil Kumar Garu on the day one, when he was telling it, whatever inputs you give it, you will get any output out of it. Drain in, drain out. You give a better, input, you will get the best output. You give whatever input, it will be giving you. And if you observe it, this is your measure. I'm not interested with this particular measure because this is highly coarse. I'll go with, fine mesh. Generate. Yeah, fine mesh is being generated. Now, your job is done. If you want, go back to your workbench. Yeah, update the project. It is updated. And here, if you observe it, beneath you have a progress, and it has a message saying setup component in flow over car fluent requires user input before it has to be updated. So it is waiting for this, hence go to setup. So Fluent launcher, good. This is how the Fluent launcher is. It is already, dimension is 2-dimensional it is taking. Go with, double precision. Generally, I have situations wherein I am going for, computational fluid dynamic analysis of, gas turbine combustions. Or, a vehicle wherein I want to do exhaustive CFD analysis. I have to go with, parallel processing. I want to go with parallel processing rather than serial. Serial for small jobs, where your iterative steps are around 10 to 15,000. You can go with serial, but whenever you have a very complicated situations, in such situations you have to go with the things where they are split into multiple jobs. We call it as parallel computing, and you have to identify a number of processors. And from that particular processors, what we will do is each processor will do a job, get the solution. That solution is again updated in the server, and the server will give back the solution to that which is doing the post operation of that particular. Likewise, solutions are done at same amount of time in numerous, which is definitely not even my scope. It's been trying, but we are not finding such a big jobs. So. Yeah, going to start it. Good. This is where the Fluent is. This is the beauty of Fluent. You can see that wonderful, color image map of Fluent. If you observe it, pressure-based equations, pressure-based solutions, that's why you see PBNS. PBNS, pressure-based. Suppose you go with density, it becomes, density-based solutions. But wherever you are talking about, compressible fluid flows, you talk about, density-based solutions. As long as you talk about, incompressible fluid flows, yes, flow over and across, high-speed vehicles, within its boundary layer is slightly incompressible, and outside boundary layers are, compressible fluid flows. But it has a Mach of around 0.3. So let's not go into the aspects of, elastic fluid flows. So pressure-based, absolute. I can go with steady or transient. So initially I'll go with, steady state analysis. And wherever I have a complicated geometry, and if it is axis symmetric, I will never, model the complete thing. I'll only model the one which is symmetric. Then I can go with, axis symmetric situations. So then the next step is you have to check. This is the very important thing. Your mesh has to be checked because the volume should never be zero. That is why we call in analysis, anybody can do geometry, anybody can make analysis, but meshing is always a complicated aspect. We always have, softwares like, HyperMesh only for meshing. In fact, defense organizations don't rely on, commercial software because they ping the data in and out. They write their own codes. Python is one particular language. Earlier we were using MATLAB. Now we were being using SimScale. We're also using, there's one more, one for MATLAB. We are using Scilab, Scilab. We are using Scilab to write our own solvers, and then all these things can be raster draft on the situations. So check, done. You can report quality, yes. Then you can even swap. You go to this, ask it if there are any areas where, because you should be knowing by now that the finite element methods are only approximate methods. All mathematics which you have learned in solving differential equations using numerical techniques has been used. The background, you can see that, continuity equation, you can see momentum equation, you can see energy equation has been solved. So all this is dependent on your grid sizing and relaxation techniques. So wherever if your mesh is not smooth, you have to smoothen it. Smooth, done. So there is around 0.1% of the cells that are being worst. So we did it because solutions sometimes will not converge if your mesh is not in a proper way. Then we'll go into the physics. I'm telling you, unbelievable, physics is here. I'll just show you. I'll just tell you. Say, suppose you want to do some, what I mean to say, some combustion things, species. Or you want to go for chemical thermodynamics, this one. Or if you are looking at, multi-phase fluid flows, you can go with. That means you're looking at, water vapor as well as, water. Adiabatic saturation situations, you have to use this. Or you have a situations where you have a solid phase as well as a vapor phase. In the process of solidification and melting, you can do it. So you can do a lot. You can go with, I'll be using only two things. One is energy equation. I'll enable it. And there is, laminar. I'll just, try to run. Let us see, are we getting convergences or not? We'll try to go with, inviscid, laminar. We'll go with laminar fluid flows. And you're very aware that, laminar fluid flows are those where one particular layer slides over the other particular layer. Or in other words, I can say that it is one particular layer where it is dominant more by, drag. Drag coefficients are higher in case of your laminar fluid flows. Shear stresses are higher in case of your laminar flows, where streamline flows can be observed. I can go with, various orders of turbulence. If you want to complicate physics, just move away from your laminar to your turbulent situations, you'll be knowing it. So what I'm doing, I'm going with a laminar. That's all. I have enabled energy, I have enabled laminar fluid flows. And if you're looking at materials, yes, air. And properties of air are being given. Suppose if there is variation of density, I can go with it. Say suppose I'm keeping it constant as on now. Or if you are having piecewise linear polynomial, that means density will vary with respect to temperature. Yes, it happens so. So I'll try to denote that particular temperature. Say suppose over here, I'll say some 300 Kelvin. Rho is a polynomial function. I'll write it as A0 plus A1 into T plus A2 into T square plus A3 into T cube. We call it as NASA polynomials. NASA polynomials will give you, piecewise linear profiles. But as of now, I'm trying to see to it. That's what I was telling you. You can complicate physics over here. You can understand various scenarios. You can compare everything. This is a specific heat, thermal conductivity, viscosities, change and create, done. And I'm trying to take aluminium. Then boundary conditions. This is the one where you require a proper understanding. Inlet wind tunnel, I am giving a velocity inlet condition, and velocity inlet I'll try to give some 15 meters per second. 15 into 3, around 50 kilometers per hour. So I'm just starting, because when velocities are around 50 kilometers kmph, 15 meters per second, I don't observe that it will be in a laminar, it will be in turbulent situation, because Reynolds number within a rectangular conduit may not exceed around 2300 value, rho ul by mu, or rho u dh, the hydraulic diameter is again corresponding to the frontal area of your car. So I am assuming that as per this 15 meters per second, rho is around 1.25, velocity is around 15, hydraulic diameter per unit width of it may not be more than around 0.1 meter, and divided by the value of mu, though mu is of the order of 10 to the power of minus 6. I am trying to take frontal areas of the car is of the order of 10 to the power of 3, less than 10 to the power of minus 3 over here, 10 power minus 6 and 10 power minus 3. So 10 power minus 3. Overall, when you try to multiply, I am expecting that it is less than around 2300. Or you can just put it on a paper, we may get it. And I am trying to take its velocity is this. I am trying to keep it as, we can give components. Sometimes if you give components, you can give x velocity and y velocity. That means, say, suppose you are giving both values same, 10 and 10. So I am assuming that it is at 45 degrees, angle of attack. As of now, I am trying to keep the angle of attack to be normal. Magnitude, yeah, this is magnitude, normal. And then I am trying to keep temperature 288, ATP conditions. Okay, then exit of wind tunnel, it's not a wall, I'll call it as outlet. I'll call it as an outlet. Air is going out. Then ground is a wall, ceiling is also wall, whereas when you come to vehicle body, edit, it is not a stationary wall, it is a moving wall. And what is the translational speed? X direction is 1, Y direction is 0. That means it is moving only in X direction. Suppose I say it as 10 meters per second, or I'll give it as 15 meters per second. There is no slip. Suppose if I specify slip, I have to talk about boundary layers. I have to look from standpoint of what is the boundary layer aspects of it. No slip. And I'm assuming that I can also discuss what is the temperature, what is the heat flux, if it's an internal heat generating body, what is the convection, radiation. I can go with FSA, fluid solid interfaces, because in workbench we will do thermal analysis of solid, estimate the heat flux, and then link that heat flux solution here. That is how we will do it. So I will specify that the temperature of this particular vehicle is around 330 degrees centigrade. Because of solar radiation that is falling, and inside it is completely conditioned, air conditioned. Now this is vehicle. Now reference values, if you look at it, compute from say inlet. These are the reference values. area, we are taking 1 square meter frontal areas. If you change these values, you can get better drag values. Pressure Pascal is 1.01325 e power 5. He has not indicated that whether it is gauge, so I assume it to be absolute, and then write this reference. Then solution methods. This is semi-implicit pressure linked equations. You have various solvers. Then you will do all this when you try to go at a higher end. So what I'll do, as I'm doing it, I'll also change this to turbulent conditions, so that you will see. I'll initialize the solution. Start from inlet. Initialize. Run calculations. First I'll go for 100 calculations. Yeah. Yeah. I can see all that, dancing lines. Those who are with fluid dynamics, they understand that you have continuity. White is continuity, x velocity, y component velocities, energy. So again I'll ask to run for this. A reverse flow. Reverse flow is always an issue. Okay, I'll give somewhere around 300 calculations. There's a slight reverse flow that's we are observing it. We'll do one thing. Go with laminar initially. Try. We'll go with hybrid initialization. Run calculations. Let's ask it to calculate. We just change the model. Good. It is also showing some reverse flows. Ask it to sometimes it takes more and more amount of time. You can go with solution controls, energy 0.9. You can sacrifice a bit. Ask to compute again. Yeah. Keep trying. One particular point you get convergence. Anyhow, I'll just show you how this particular situation is looking like now. Those are contours of your pressure. Look at it. These are contours of your velocity. That's a contour where you're observing temperature. I'll go back to model, change it to K epsilon, initialize the solution again. Then go back, change the solution to transient, come back, number of time steps, I give some 20. So I'm giving around 400. Now this is transient, time based. I'll just wait. If solution converges, converges. If not, there's no issue. Because I tell you, with my particular experience, sitting on 8 GB RAM system with huge memory, I will say this particular system is running, but working on a supercomputer may also take solutions of turbulence to be converged within a time of 24 hours, 24 to 48 hours. So you observe, say suppose display pressure, display velocity, but turbulence. I am interested in turbulence. Yes, that's it. That is what I was expecting. In fluid dynamics, we read about a concept known as von Karman street. Von Karman street is that whenever high-speed vehicles, pass over you, they leave out a region of wake at the back. This particular region of wake is specifically observed in automobiles, and most of the accidents that occur for high-speed vehicles is because of this particular wake, which you call it as von Karman street. By the way, please don't experiment it. But if you observe, if you are going past a high-speed vehicle, you observe that you are being dragged into the line of direction of that particular fast-driving vehicles. So vehicles will lose lateral stability because of this particular wake. If not, if you still want some scientific evidence on this particular von Karman street and the wake formations behind this high-speed vehicles, just refer to high-speed gas dynamics by Anderson. You observe very clear. It's very clear. So you make all this graphical things. Suppose I want to visualize path lines. I want to visualize path lines. Path lines starting from, say, suppose inlet. Yeah, that's it. And if I want to pulse, I'll pulse it. I can see how they are moving out. That means my geometry is not proper. See, whatever geometry I have just drawn over here, this particular geometry is for understanding. I told you, my geometry is very simple. I have not complicated the geometry, nor I have taken the particular geometry in line with it. And if you observe it, these are your path lines. So suppose I want to know how there is variation of pressure. Say suppose pressure variation across the vehicle body. I'll ask it to plot. It is giving me the regions of high pressure as well as your low pressures. Because of this difference in high as well as low static pressures, I am getting lift. I am observing that the top surface is having a lower pressure and bottom surface is having a higher pressure. Thereby, pressure into area is a force and a net unbalanced force is in the direction perpendicular to your reactive surface. That means it is above, in the direction opposite to your weight. Thereby, you have a lift. So there is a clear evidence that the vehicles will lose lateral stability if this particular differential pressures exist over the surfaces. So there is one more very exciting thing. If you observe it, because my other colleague is waiting, 2 minutes. Vijay sir, just put a word to Gajanan sir that I'll try to close it within another 4-5 minutes. I'm in process of conclusion because sir is controller of exams. Let us not ask him to wait for some more time. So if you observe, now this is one exciting thing, results. This is post-processing of fluent. Yeah. Meeting number. Gajanan sir. Dr. Gajanan sir. Gajanan sir, another 5 minutes, I'll just take it and then try to close it up. Yeah, this is your, post-processing solutions. If you are looking at it, this is my inlet of wind tunnel. Now, I am interested to see visualization. Students, researchers, everybody want visualization. Now, how fluid is flowing? Because it is very difficult to understand the dynamics of the fluid. So I'll try to go with some streamlines. I'll ask it to put a streamline. Put a point 50. Good. Yeah, I didn't put up from where it has to come. That is how my fluid lines are there. Now I'll try to animate. Life is all with animation. I'll try to see some slow, very slow. And I'll try to record. I'll say save movie. And then I'll say play. Can you see that, velocity profiles, it is, fully developed velocity profiles within that, and suddenly you are observing
excuse
that.
me, sir.
Yeah. Oh,
Sir,
1
I'm
minute.
so sorry to disturb you again, but then your screen is not visible.
Yeah, I'm sorry. I'm sorry. I'm really sorry. Why? No post processing. Yeah. Yes, I can just take up again. All right. Yeah. That is, the fluid flows within your wind tunnel. You observe bottom layers are dragged now, if you see, because of the impact, and because of that you see that parabolic profiles, and you observe that static velocities are increasing. That's how it's going out. Catastrophic for the top land of your vehicle. It gets immensely heated. It gets immensely heated. You observe such situations. So suppose I want volume rendering. I don't want this. I want volume rendering, or somewhere. This is where volume rendering. So I want to know how pressure is. Yeah, that's how the pressure domains. Say I want eddy viscosity. Because this turbulence, you can see that eddy viscosity. I'll try to remove that streamlines. Yeah, I'll ask not to show me the streamline. Yeah, I can see it is leaving out the regions of turbulence at the end of your car. That's the region of negative pressures. That's the region of your wake. That is your one Carmen street, where low pressure regions are being created. The vehicle it just moves out. I'm just given a 50-55 kilometers per hour, and when you try to iterate it at higher speeds, at one particular point your solver says turbulent viscosity has been increased more than 5,000, and hence you have to use a different solver to do it. So suppose if you look at pressure gradients, if you look at your velocity, that's how you have velocities, whatnot. Wall adjacent temperatures, if you observe it, that's the wall adjacent temperature. That is your convective heating, aerothermal heatings. And mind you, if you talk about a vehicle moving at Mach 1 or Mach 2, supersonic missiles, cruise missiles, enormous amount of heating has been observed on the surfaces. You call it as ablation, self-sacrifice of the materials happen. And this is a small situation wherein you are having a temperature of 296 Kelvin from 288, localized heating. It can be taken up. So I will back to my 1 minute. Sir, Gajanan sir, 1 minute, sir. My life is all moving around these windows. So this is what I was doing it. This was for sedan. Whatever I did it is for hatchback. Then these are the contours, shear profiles, path lines, eddy viscosity generation for your sedan vehicle, kinetic energy dissipations, velocity in x and y direction. Then I made a hatchback, the convergence criterias, pressure profiles, velocity profile, temperature profiles, turbulence profile, strain rate profiles. This was done at higher speeds. So to have lateral stabilities, lift and drag coefficients are computed as per dynamic pressure coefficients, because if you go back and see at that pressure, you have a static, dynamic, you have different pressure coefficients, and quantified as per CD and CL values. These values will be obtained by providing the reference values and frontal area with velocities. The future scope of work, there's excellent shape optimization. Industry calls it as topology. Then 3D analysis over moving automobiles, high memory computations, artificial intelligence, MIAL are taking up these particular areas. Validation of results by experimental investigations. So I thank you all, because time is, I have stitched my own time for very less amount of it. Hopefully I may get back to you. This is my contact information. Any information you want, you can also contact me on my mobile, or you can mail me. It's on small letters. MVSREC.edu.in, and if I have any questions, I am ready to take it.
No questions as of now, sir.
Thank you very much. Yeah, Vijay. Thank you. We are all house, so in-house people are all on same platform. Thank you very much. Yeah, I will try to take up the opportunity of introducing Dr. S. Gajanana. Vijay, do you have sir's profile? Yeah. Yeah. Sir, Dr. S. Gajanan, sir, you're welcome for this one-week national level conference on innovative methods in finite element methods using ANSYS and ABAQUS. For benefit of audience, I will take up a minute of time and introduce Dr. S. Gajanana. Dr. S. Gajanana was earlier the professor and head department of mechanical engineering. His specializations are in the areas of production technology, forming, optimizations, operations research. But now, most of the areas pertaining to the new generation things. Presently, Dr. S. Gajanana is holding the position of controller of examinations, MVSR Engineering College Autonomous. In spite of his very hectic schedule, he has taken up the topic to come down to the conference, workshop, and then deliver his lecture. Dr. S. Gajanan is very versatile academician, administrator. Above all, he was the first head of the Department of Automobile Engineering. Under his stewardship, automobile engineering has taken up the shape. And the department has a complete gratitude towards the contributions that have been made to the Department of Automobile Engineering by Dr. S. Gajanana. Sir, with these few words, I would like to welcome you for this, and please take over.
Sir, thank you very much, sir.
Thank you.
Are you able to hear me?
Yeah.
Thank you very much. Whatever the introduction is made, he has exaggerated, because Sharma sir is a good friend of me. I'm only a teacher, basically. I would love to be teaching. Moreover, a teacher has always to do something extra. So that extra part I am doing as a research. Yeah. A few things I would like to share with you. My voice is clear? Hello?
Yes. Yes.
Yes, sir. My voice is clear, I think. Yeah. A few things like whatever the works I am continuing now. Under me, 10 people, 10 research scholars are working. They are continuing the PhD in the areas of manufacturing, production, and industrial engineering. 3 PhDs are awarded, and 1 has been submitted. Remaining 3 PhDs are completed and they are writing they are in the report stage. And apart from it, around 70 papers, research papers I have contributed. I have completed one minor research project, UGC, sponsored of 5 lakhs. And a book is also in the process. This is a few extra information I would like to furnish to you. Yeah. So the topic that I was given, I would like to just share this window. Are you able to see the screen, sir? Yeah. A few points I would like to share because the topic that it has been selected, scope of ABAQUS in research, that we can divide into 3 parts. First one is what is the research, and next why this ABAQUS, what is the importance of this ABAQUS, how it can be used in different areas. That is the second part. And third part is how do you integrate this ABAQUS tool into your research. These are the 3 segments are there, and it may take more than 2-3 hours. But I would like to just throw a little bit light on that, a gist of the 3 parts I would like to present today. Basically, if you just Google in the internet, say what is research, you find some wonderful statements given by many of the researchers and many of the scholars. One of that I would like to just present here is research is to see what everybody else has seen and to think what nobody else has thought. See, I would like to ask a question to the audience. Anyone can answer. Earth is having gravity of attraction, gravitational force we call. Who discovered it? May I get that answer from any of this participant, please? Isaac Newton. Right. Can you just detail the story of it? Any idea about the story of it? How it has been done, discovered? Okay. Okay. Right. You are very correct. May I know who is this? Yeah, Vijay. Correct, Vijay. As you said that Apple was just it was falling on him, and he was looking at that why Apple is coming in the downward direction only. Why can't it go in upward direction? That question was raised in his mind that led to the discovery of the gravitational force. Right, here the statement, I can just add that example, what you said, the story to this statement. Before Newton, or when the Newton was there, around him so many people are there. They have also seen the apple, they have also seen the apple falling downwards only. But Newton got a question, why this downward only? That instinct, that sort of property a mind which has is a research mind. That's what everybody sees, whatever it is surrounding, we observe, everyone observes. But everyone cannot think in a different way and interpret the things, the same things everyone what they are seeing, interpret in a different way. This is the first property that is required for a good researcher. When you think in a wild way, in a different way, in a questioning way, in an unsatisfied way, then that is the best property that you have, and you will become a very good research and you can complete the research. That is a skill that you can have, whether if you want to go for research or register your PhD, whether I have that instinct or not, you please judge yourself. If you feel that I have, then I can assure you that you will certainly get a PhD. Right. Because my topic is how this ABAQUS is used in the research field. Before that, we should know some facts, because this is the experience. I'm continuing with research. I am producing the PhDs. I have already produced the PhDs, and in different problems. One in the optimization and operation research, one PhD successfully completed. One in metal forming area, that is the metal spinning area, and one more in rolling area, that is a metal rolling area. And next, one more in the metal cutting area. These are in the different fields. In the different field, I have experience. It was just like walking into this wild forest, very thick forest. You don't know where the route ends, whether you reach the destiny or not. But you have to make the route, make the way and go and see. You will certainly experience, but at the same time, you will also find some hurdles also. You have to stop somewhere where you cannot cross that. But one confidence that you have to develop is, yes, I can get it. And think, whenever you get stopped there, think, what are the ways to escape from this hurdle? That is the basic property, or we can say the attitude a researcher should possess before he starts the research. A wonderful quotation or a definition, we can say, regarding this research. The systematic process of collecting and analyzing the information data in order to increase our understanding of the phenomenon about which we are concerned or interested. This is a definition which you can observe in any of this internet. Google it, you will find it. Means, if you see that, first of all, when you want to do some research, like PhD, you want to continue, you need to find out an area, then you need to find out one particular title for that. Under this title, you have to put a problem, a definition for it. After the definition of the problem, you have to again elaborate slightly what are his objectives, what are the expected outcomes of it, then how the procedure, you have to develop the architecture for that particular problem and start doing it. Here, whenever you, sorry, whenever you are doing that, you have to verify a little bit alert. You should have the same idea, the same problem has been done somewhere else, or it has been done earlier. That you have to verify. That is very, very important. For verification of your problem, whether it has been carried out earlier or carrying out, is led to the research, and this we call it the literature survey. Survey the literature. Now this generation is very fortunate enough, because lot of facilities are available, internet facilities are available. Just you sit in front of the system and click, access the net, you will get all the data, up-to-date data which is available. There are many sources are available, free and also payment sources are available, which can provide you whatever the field you want to carry out the research, what is the status of it, updates of it. So in the first research work, whenever you want to carry out, this is the basic structure that is available. Or every guide he says, suppose my specialization is in this particular area, I am doing this research in this area, I will just give you one title. You find out that any work has been done under this title and what is the content that has been carried out so far, what is the status of that particular, that we will verify. So whenever you go for any research project or research, it starts with a problem, definition of the problem. There are two types of research are there. One, I will select my area, I will explore the problem, I will find or I will develop the methods, and I will do some alterations on that, and I will find some of the outputs of it, and I will present that outputs as my findings. That is one way of research. I mean, whatever the findings are there in my area, this may be useful for the industry, or it may be useful for further research. This is one category of doing the research. But second category is there, what is required for the industry, or what is required for the research institution. Take that particular problem and try to solve that problem and find the alternative methods for improvement of it. There is that you have to get a clarity about here. Here is this type of research projects can be called as a consultancy type, but consultancy is object oriented. The end result should match with whatever the procedure that you are following, and your procedure is restricted there. That is called a consultancy. But in the output oriented project or research work, where the industry needs some sort of output, you can explore the various methods. You need not stick on to that particular methods, but you can explore the various method, and you can go for the different other areas also. That is called the interdisciplinary areas. Nowadays, computers, in the area of the computers, we have a different categories, or the new type of topics have been developed, new type of things have been developed, like the machine learning or deep learning. These are all some sort of tools or technology which has been evolved. Those technology can be incorporated so that your accuracy of the problem enhances, and also the efficiency and time of execution also comes down. Error will be minimized in your work. That is the intention of going for the interdisciplinary type of projects. So the two type of research generally we can carry out, but begin with a proper selection of area, and also try to link up with the other areas which are completely different domain, maybe electronics, or maybe computers, maybe electrical, because we want to take that flavor of that into our own field. Recipe, it can be developed by adding the different type of ingredients, that you have to remember. Coming to this, after definition of this problem, and for every researcher or the supervisor, they find difficulty in planning the work and also defining the particular problem. Defining the particular problem is a big task. Many people, they fail in research because they could not reach the target which they have framed in the initial stages. That is called, the blueprint is not correct. The blueprint, whenever we call it as a blueprint, means which is correct, which is just like a Bible that we have to follow, or Gita that has to be followed. So many researchers, they are the supervisors, they fail when you don't have the proper blueprint. First thing to start with the research is, you frame the blueprint. Wherever there is a scope of that you are not accurate what happens that particular stage, just leave it and try to provide something can be accommodated there. In this way, you have to prepare this research blueprint. The good research requires the scope and the limitation of the work also, right? So second thing is, when you have prepared the blueprint, the blueprint has to give the information that what is the scope of it, means what is the how best you can do that work, and under what conditions, what are the not possible things are there, what means limitations or that assumption that you need to carry out in order to reach that particular problem solved. And the process has to be clearly explained, that it can be reproduced and verified by the other researchers also. So one thing, the citation, one word you might have heard. One particular paper, if it explores the new topic, new thing, then everybody starts working in that area. And they start working in that area, they refer that particular, the first paper which has given a new dimension, new light which has shown. So that new dimension, the other people also try to travel in that. So during the travel, they take the path of the first paper, which we call as a citation. So if your work is good, if it is the innovative type, then you have a better scope to get it done. And also after you, many people may come and also follow your path. So citation possibilities will enhances when your work is very innovative and multidisciplinary also. A thorough plan, design and objectives, whatever the possible objectives are there, whatever the limitations are there, what are the expected outcomes are there, you thoroughly have to mention or just frame it. And all the limitations that have to be documented, because when you present your work, you feel that you may be asked why this way, this method is correct, why this method cannot be explored like that. So that's what I use the word called the blueprint. When you fix we call the blueprint means the blueprint has the boundaries. So when you frame the boundaries, then the whoever the questions you, they understand that what are the limitations and under what conditions you are carrying out this problem. And a collection of the data, sufficient data to defend your work is also very important. And once you got the results, that results has to be thoroughly analyzed. Why this particular value is coming for this process? What made it? What is the influence of it? Which parameter is getting influenced? How can it be moderated? How can it change? All these things of exploration. You have to do the multitasking type and explore the possibilities and give you proper reasons for the results that you have obtained. These are some of the points whenever you start the research that you have to keep it in mind. And what are the characteristics, means that the properties that every research should possess is, first of all, as I told you, that finding a problem is a big one, a big task, and a clearly articulation of the goal. If you start with this problem, what will be the result or end result that you are going to get, expected results? Or is it in a favorable or not favorable? That is one important point which is required. And a specific procedure of plan. What is the methodology you are following? If you stay first A plan, next B plan or C plan, all these are same, or you have to iterate it, A plan, C plan, D plan. What plan that you have to adopt or procedure that you have to adopt which can meet your end goal. And often divides the main problem into sub-problems. Remember, always try to make some modules. And division and integrating. These are the two things that should make properly in the research work. Division means divide into different modules. You can work on the modules independently. And later, there should be a common module or common link that should be available. Like, you take the different type of flowers, or you can take the different size of pearls, but all the pearls can be connected with a one thread. So you should possess a thread which can connect all the pearls so that you will get a beautiful pearl, a jewel. And guided by a specific problem and hypothesis, what is the base for your start? Base for your start should be it should be very strong. And to get the strong base, you should do the exhaustive type or elaborate literature survey that has to be carried out. And accept certain critical assumptions also. See, there are two types of parameters generally we observe, a controllable type of parameters and uncontrollable type of parameters. And you need to identify when you are taking the parameters which are controllable, which are not controllable. There are semi-controllable are also there under certain conditions. Those elaborately, if you can categorize it, and what parameters you are dealing, why, these two questions you should have a proper answer for that. And once you complete the work and come back and you always try to make as a closed loop, don't make it as an open loop type. Say 4 modules, you have done the work into 4 modules. Okay, wonderfully, you have done all the modules completed. When the different 4 modules are there, how do you interlink these modules? What is the correlation among this module is a very, very important task. Many of the people, when the supervisor says, they go on doing all the different modules and later they find the difficulty in attaching those modules. Like wonderful shirt, wonderful pant, everything wonderful dress you have, but it is not fit to a particular people. Okay, but once you take a particular size, to that size it has to fit. If it is not fitting, means you might have done a wonderful individual modules, but it is not giving the ultimate result what you are expected to at the end. For that, you need to have always the integrated mode. First, you divide into modules and integrate in a proper way. I will show one example here, which has been carried out in this research, in this project. PPT. I will show that. Yeah, steps in making a good research. Most of the points that I have just discussed. First of all, you identify the area, raise a question in that. That is the frame, the title. The title should be always. It should be always scope should be there to change it at any stage. Don't go for a apex type. Always try to be a flexible title. You can change slightly here and there. Adjustable type of title is that you have to make. And what hypothesis that you have to consider, and literature reviews up to whatever it is possible is there. Suppose it has been, the work has been carried out in 20 years back. Yeah, try to get it up from there. And there is one very easy method most of you might be knowing. If I get one paper which is related to my work and other papers related to that, you can be obtained when you see the references. In the references, you find the paper, some papers which are directly related to your work, 100% related to your work. Okay, but like which difference means based on those paper only you are enhancing, further moving to the other level of work. Those papers you identify. Again, take that paper references. In this way, you form a closed loop, checking loop, so that you can get a maximum number of the literature available in that particular area which you are doing. And evaluate the literature. Evaluation of the literature means basically every paper, whatever the research, the findings they have done, what finding they have missed in that particular, the framing, they have framed one topic, framed one way. In that particular way, what path they have not explored, you list out. It means whatever they have missed, that becomes a scope for you further to do your work in the next level. And try to get that information, data related to that work. And this data, how far it is relevant, how far it is useful for you, try to analyze it, interpret it, and those data can be further processed using a new technique of this enhanced method of it. Yeah. So this is regarding the research work. Given some, this is all the things are my experience I have shared. So after successfully completing the 4 research PhDs, that is research works for PhDs, I understood. I got some clarity where I am missing. Every PhD work is a new dimension for me, It is a new lesson for me. It has enhanced me. It has improved me for giving the better inputs, better ways for the next coming PhDs. That is the experience I am sharing with you. And one more thing is, recently won award at PhD in the area of metal spinning. The title, it was experimental studies on metal spinning, analysis, optimization and process parameters. In this PhD work, I have used this ABAQUS. What made me to use the ABAQUS, why I have been used the ABAQUS, that also I will discuss. So before that, this research work has some industrial flavor. What flavor it is added to this in the research work is, if you see that commercial and non-commercial and also domestic, non-domestic, scientific and engineering, research, all equipment, certain equipments you find. So this is the process which we call deforming the sheet metal into the required shape by applying the pressure, force, sometimes the heat also. That process is called the metal spinning. In the metal spinning, broadly there are two categories are there. If the thickness of the sheet metal has been reduced and to get the final shape. Look at this final shapes you can see. This is the aerospace parts, various types of parts. There is no, a single material will be deformed to the required shapes. Most of the materials of the sheet metals, maybe around up to 5 mm or 6 mm, depends upon the application and size of it. This area has a scope. So why it has a scope means, so if you want to get this aerospace parts or missile parts, so it's a costly affair. You should, and the materials which they are using are very costly materials, because they have to withstand the high strength and also the high pressure temperature. That's what the raw material cost is very high. If you waste the raw material, your cost of manufacturing will go on increasing. For that, you need to find out what is the proper, the parameters, input parameters that has to be selected, so that without much wastage, you will get your final parts. So there, particularly at that particular situation, we need to act our, give the solution, act and also give the solution. What are the best parameters, optimum parameters that we can select for this particular way? And after getting the parameters, for that we need to do some experimentation, collect the data. The data has to be analyzed, and see, when you do the experimentation, you find some sort of the behavior of the material. The behavior, internal behavior of the material can be approximately studied by using the FE packages, FE software or tools. So that is the basic necessity of the tool. So in that FE tools, we have, application wise, ANSYS is also there, and ABAQUS is also there. ABAQUS is versatile, means used because it can take the many parts. It can have a minimum or less number of type of errors during the formation of the finite elements, and also flexible usage, modules. All these are the strength for the ABAQUS. That's what it is popularly used in industry, ABAQUS. And here, the purpose of using the FE tool is, when you deform the material, when you try to get the initial raw material shape to the final raw material shape, there may be some internal properties of the material may be affected, or it may be slightly deviated. Just like one of this property, we can take the what is the strength of that material, initial strength and final strength of the material, whether it has gone some sort of hardening, or it has stresses are developed during the after formation of it. All these things can be analyzed, and where is the weak part that can be observed, and where is the chance of getting failure. This, if you do it in case of FE, if you use the FE and do it, that will be very useful for the industry, because once you test it, once you make and test it, then only we know that why that failure happens or why it has been success. But the beauty of this software, either you use the ANSYS or ABAQUS, is it will give approximate idea for a manager what is the behavior, how this part will be behaved, what sort of properties have been changed when you adopt this particular type of manufacture for the using the particular set of input parameters. And the second thing the manager or the engineer would you like to have is what is the number of iterations that I do to get the best input parameter should be reduced. In one or two stages itself, I should get the final part without much error, acceptable final part without much error. For that, we need to do certain iterations following some methodologies and give the best suitable parameters and what is the minimum force that is required to get the final part will be the a problem, particular problem here in this research work. So in this research work, basically, first of all, I have prepared the blueprint like this. Hello? Are you able to hear me? Yeah. So far it is clear for you? Can I stop and you would like to interact with me or shall I continue? Oh, no problem. Okay, fine. See, this is the blueprint that I have prepared before the start of this research. So I have divided into the four modules. Initial module is it studies about the area, what area that you have to select, sub areas, and also particular areas, a bigger domain, middle domain, and a simple domain. In that particular domain, one point that we have to touch so that our problem can be defined. That forms in the first phase of it. In the second phase, it consists of the different type of tools that will be used, different type of parameters that will be selected, preparation of the material, which is nothing but the preparation of the material, and also forming your objectives, and also selecting the proper tools, raw materials, and methodologies that comes under the second phase. In the third phase, you have to make the three different type of cases, or as I told you that you can delink it, you have to make the division as a modules and integrate those modules with a particular type of a thread. That particular thread is very important, which can integrate all this differentiated. We divide the modules and we elaborate that module clearly. It will be easy. Then elaborated module should be linked with the main, a mother module. So these child modules, when they have grown well, that has to be brought to this original mother module, parent module. So that interlinking thread is very, very important. Here in the spinning, we have taken a metal spinning of three type of profiles. One is development of cylindrical module, because if you see here the different type of components, most of the components are conical component, parabolic type of component, and cylindrical type of component, and mixed profile components. So we have taken the three type of components here: conical component, cylindrical component, parabolic component. So for this we have done experimentation on the spinning by using the ENite material I have selected, and also we have developed the new tools here. What is innovativeness is the tools they use, whatever the tools that conventionally use or in the CNC they use. Apart from this, we want to develop a new type of tools that is nothing but which has a double radii type of rollers. I'll just show this. Yeah, here you can see this is a single radii, a circular type of tool. Yeah, this is the double roller, and this is the double radii roller. Means one after the other, the contact points will be there. Sometimes there may be two contact points. Here is the single contact point of deformation. There are the two different contact type, but spacing is more. So this type of use depending upon the suppose when you go for the parabolic type, and also when you go for the cylinder, this one conical type, this type of roller tool will be effective. And one more tool we have developed is here is the double radii. Then this is a single piece only, whereas you find two different contact points, slightly that semicircular type, and we have a single two contact points very nearer to you. This type of tool, it has given a good result in some cases. Right. And these are the different profiles we have selected. cylindrical mandrel and conical mandrel and parabolic mandrel. So this total experimentation is carried out in-house only. We have used this conventional lathe here. There is a possibility of what are these parameters, input parameters that we have selected is speed, thickness of the sheet and type of roller. And these are the very important three parameters. By using it, you can get the final shape of it. Right. Okay, the three type of modules you have made. But what is the interlinking of these three? That is very, very important. The thread which is going to interlink the three different profiles is a geometry. First of all, we have taken a straight line geometry, that is a cylindrical. When the geometry is straight line, when the geometry is inclination, means here the direction of flow is constant. Say, here the direction of flow is in a particular inclination, whereas this direction of geometry is changing at every point. Means when you take the geometrical direction as a thread for these three, that will be a linking point for this particular project. And this particular project has been, during the Viva, it has been appreciated by IIT Chennai professor. He was the expert, subject expert at that time, Viva examiner, and he appreciated the way it has been interlinked, and he told to continue this by using the CNC machine also. So whatever the limited facility it is available, with that limited facility, we tried the best. So researchers should possess always that your innovativeness should come, but not the facility should dominate your idea. This is a very, it may be a not sophisticated facility, but your innovativeness has dominated this facility. If your idea, innovativeness, if it is attached to the CNC type, you will get a better results and a better quality products may be possibilities out there. Yeah. So this is the blueprint as I told you. Now, how this definition of the problem, right? Metal spinning, we want to carry out in the three stages. One is the cylindrical stage, one is the conical stage, and one more is the parabolic type of stages. Here we have used, to generate the data, we have used the Taguchi technique. Taguchi technique, it will take the input parameters and the different levels, and we experiment it. So initially this is the straight, here we have used aluminum material as a work material, 2024, L2024, and it has been deformed to the shape. And when you deform it, we have to take the number of trials. Those trials have been generated by using the Taguchi, and we find the spinning force. Spinning force can be obtained from the dynamometer which is attached. You can see that roller will be inserted, and the dynamometer is, you can see this roller is inserted in the dynamometer and it is going to deform it. So for the cylindrical, we got the data like this, spinning force. Here the objective is we need to find out what is the minimum spinning force occurs, so that you can save the energy, and at the same time, what is the optimum values to generate the minimum spinning force. So in case of this cylindrical, hello? Pardon? Yeah. Yeah. No, I will just complete it within 5 minutes. You just give me the 5 minutes. So let me complete it. So you can see this physical components that are available. Similarly, for conical also, we have done this a conical shape. You can see there are some failures are there because the facility is not that much sophisticated. So we have just fastened this job to this mandrel by means of the bolt. Okay. And we got this correlation. This is the correlation between the spinning force and also the material. This will give you enough information what is the optimum parameter that you can be selected. Yeah. For this conical type is over, and next parabolic type. These are the components obtained from the parabolic. Yeah. So we have the same thing we have simulated using this ABAQUS. So you can see the deformation in this ABAQUS. You can find out where the weak points are there, where the more stress has been generated, how the failures can be obtained, how to control the flow direction of the roller, and also that how what parameters speed has to be increased or decreased. That and all information can be obtained by looking at the stresses that has been developed. So for the different stages, by using the single roller, double roller, and validation of important means, see the whatever this physical experimentation when you do, the values that are obtained, how they are going to be fulfilled or matched with the simulation values. So we have seen the simulated force. If you see that simulated force and experimental force, you find the spinning force experimentally for one particular case here 72.94, whereas the same spinning force, but when you do the FE simulation, find out 61.12. A variation of the 16.12 is there. This variation has happened because of the facility and uncontrollable parameters. If when you use the CNC, probably this may come down to a single digits. And finally, I would just show you one video. Can you see this video, please? Hello? Able to see this video? Yeah, and the simulation has been carried out by using the ABAQUS. It's a double roller. This is the stopper and a conical mandrel. It was very, very difficult. It took us 3 years of time, almost 2.5 years of time. We faced many problems here. This particular part, it was appreciated by the IIT professor who was the examiner. Because very few works that has been done. Only you find only 1 or 2 works. That are not the work that what we have done. It was a different software they have used. And there is a scope of going for the patent in this work. We are also exploring that. So thank you very much. Anybody wants to interact? Okay, thank you very much. I'm also getting calls from the examination branch. Sorry. Yeah, I got almost 10 calls now. And thank you very much. I thought of taking 15 minutes, but it went down to 50 minutes. Sorry. I'm very poor in mathematics. 15 to 50, I could not manage it. Anyway, thank you. Next time, I think 2-3 hours, if you can, automobile department can give it to me elaborately, I can go through that. Sharma sir, thank you very much for giving this opportunity to me. Hello? Yeah. Vijay? Can I leave the Vijay? Yeah, thank you, thank you.
Vijay, 5 minutes. I'm meeting with principal. 5 minutes. Yeah, Vijay. Hello. Yeah, I would really thank each and every participant, those who have enthusiastically participated for this 1 week value added course for few, certified course for few, and workshop for all, including me. The senior administration of the college is busy with the conduct of autonomous examinations. So I just took an excuse from that particular meeting and just came down. It's very formal, valedictory. I would like to really thank all the organizers, those who have made this particular program a dream come true. If you look at it, I want to congratulate two people in particular. One, Malik Saab Bhagwan, Assistant Professor in Department of Automobile Engineering, and Vijay Mantina from Automobile Engineering Department, who have made this particular workshop really wonderful, because they were been sitting from earlier 10 days talking to people, and all these 5 days, I hope they were 8 by 5, 40 hours continuous session. We had first day session with Satyam Ventures, wherein you have Devendra Kumar, who has talked about accidental data analysis, restructuring of real accidents and injury evaluations. In the afternoon, we had applications of ANSYS in automotive components by Dr. P. Anil Kumar, who just went through with all the basics in your vibrations, just created resonance among all the teaching fraternity, student fraternity and industry in using ANSYS as a tool for simulation in NVH. Second day, finite element analysis applications in metal forming by Dr. J. Kandaswamy. It's being taken up, who was professor in Department of Mechanical Engineering. Then followed by two particular sessions of static analysis and dynamic analysis by Mr. Krishna Chaitanya, crash engineer analyst from EDS Technologies. Then third day we had human body CAE modeling and analysis by Ashok Kumar Salaimuthu from Satyam Ventures. I could see that there is a lot of difference between the analysis what the academic people are doing and what industry are doing. Even I did worked in industry maybe 10-15 years back in US, wherein the technologies what people just overlook at it are being taken up as a serious concern of matter in automobiles, and that is what I could see by the analytical analysis of Satyam Ventures. I should really thank Satyam Venture people for making this thing in a right way. Then finite element analysis, applications of underwater explosions, detonations, hypersonic simulations by L. Bhaskar Rao, Lokavarapu Bhaskar Rao, professor at VIT, is really commendable. That was definitely a topic of thought, and where new research topics, those young budding engineers who are planning to do your MTech, do your PhD, want to have your career in research, this is one area where you can definitely work. Then computational fluid dynamic analysis through ANSYS Fluent by Dr. M. Vishnu Teja from IIT Dhanbad. Vishnu Teja is a proud alumni of MVSR Engineering College. He was my student, and then we used to work on ANSYS Fluent those days, 2012. He did his masters from IIT Madras, then did his PhD and postdoc from IIT Madras. Known to be very tough guy in CFD analysis, and he has promised us that everyone in this particular forum can contact Dr. M. Vishnu for any further help in CFD analysis. Then Karthik Rajshekhar, assistant professor in the Department of Mechanical Engineering and also research scholar at BITS Hyderabad, has exhaustively given the workbench introduction and how to use the workbench, ANSYS workbench. Then the morning session, as usual, Dr. M. Madhavi, my colleague, head of Department of Mechanical Engineering, has rocked, giving the topics on composite materials and how ANSYS they are using it for simulation of things. Then Dr. S. Gajanana, who was senior researcher in the Department of Mechanical Engineering and also controller of exams, have shared his thoughts on how to take research tools and his research experiences. I did a small job. I did a very small job, putting up more of a practical session than talking more of continuity, momentum, and energy equations, solving Navier strokes. So we do it at a bigger platforms. So this is what it went, and I should really thank all these speakers who has helped us out for this innovative workshop. This is an experimental workshop where we have engineering college students on board, we have diploma students, we have faculty from various engineering colleges. I take up all my energies. I'll not drop a single inch of it to thank the Department of Automobile Engineering and MVSR Engineering College Autonomous, who have made this particular event a grand success. All your certificates will follow. Those who have registered using your Google Forms and submitted all 5 days of feedback, or at least 3 days of feedback, with 60% attendance will get the certificates. So e-certificates for the faculty and diploma holders will follow, which is certificate of participation. And those students who have been registered for the CAE internships will get your CAE internship certificate at my office. So all students, please take the hard copy of the certificates at the earliest, which will be conducted next Saturday as a part of Department of Automobile Engineering activity. And I would like to also announce possible dates of April, fourth week of April. We are conducting Automobile Engineering Department Fest by name Torque. It is promoted by Student Association of Automobile Engineering, SAAE. So Student Association of Automobile Engineering is conducting a 2-day National Technical Fest, wherein we have Bosch workshop, we have Benz engine workshop, then we have RKS Motors IC engine workshops, 3 workshops. Then we have an open forum discussion on the pollution and noise that has been caused by automobiles, and should we shift it to electric variants, or we have to shift back to IC engines, how this fuel crisis will affect us. It's an open house discussion with statutory government officials of Telangana, Traffic Police of Telangana, Motor Vehicle Transport Department of Telangana, State Pollution Control Boards. Then we have advocates joining from High Court for this open house discussion. And then we have last topic is that's very exciting. We are trying to get people who want to have student interns. So earn your internship is one particular topic which we are planning it. And those who register for this particular talk and then participate in the events of our National Technical Fest can earn an internship with around 50 companies coming on campus, maybe on April 22nd and 23rd. Dates are not yet finalized, but I'm just saying it. This is one particular initiative from Department of Automobile Engineering to help students to get on board. So with these few words, I would like to thank one and all who have made this particular event a grand success, especially Vijay, Bhagwan, and there is one more chap who is always virtual. His name is Vasant Jupudi. Vasant Jupudi, thank you very much for all the efforts that you have kept in making this particular workshop success. Thank you very much. Vijay, you can close it. Vijay, you take one particular photograph, ask all the participants to come on board, or any of the participant want to give any feedback, it would be highly commendable. Sir, from can you please share your experiences? Vakada College, sir, Ramakrishna. Sir, please mute yourself. Unmute yourselves.
Sir, are you able to hear me, sir?
Yes, sir. We are able to hear you.
For me, it is rather a refresher program.
Sir.
and I'm very happy that you have exposed some of the very interesting topics. Your team has put forth some of the things which I have not seen earlier.
Sir.
I'm very thankful to the organizers.
No, I should be really thankful, sir, because you have more gray hair than me. And I could see you sitting for all the sessions, and students should learn that sincerity. Thank you very much, sir. We'll be in contact with you very shortly, sir.
Sir, whenever any program takes place, you can simply give me a message, WhatsApp message. That's enough.
Definitely, sir.
Thank you.
Any other participant? Aman? Okay, Vijay, you can call it a day. Yeah. Sir, thank you, sir. I think Srividya should have talked. Srividya has left. Thank you.